స్టూడెంట్స్ నీవు ఎలా ఉన్నారు? టుడే we are diving into one important physics concepts. Actually, not is one displacement, velocity, acceleration. These are the important, very fundamental physics concepts. Okay, so we will use that FET simulation. Already you know about that FET simulation, which is nothing but it is a tool like animation. Okay, so by this tool we can understand that concept with better okay, easy and better understanding. That's why that animation will help us. Okay, so FET moving man simulation. Okay, so మనం ఒక ఆడ లాంటి సిమ్యులేషన్ చూస్తాం. రెడీ? ఓకే. సో వెనలిల్ నాను అమ్మమ్మ వీటికి వేల్డ్ నోంచి నడచి వెళ్ళమని ఒకసారి షార్ట్ కట్ తీసుకున్నా, ఒకసారి రోడ్ పట్టణలా. అప్పుడే డిస్టెన్స్ మరి డిస్ప్లేస్మెంట్ లో తేడియ వ్యత్యాసం నేను అనుభవించాను. ఓకే, సో వెన్ ఐ వాస్ యంగ్ డ్యూరింగ్ సమ్మర్ I had walked through the field to my grandmother's village. Sometimes I took a shortcut, and sometimes I took that long road. That's when I first felt that distance, that is difference between the distance and displacement without knowing it. Okay. So first of all, we have to know what is distance. Okay. First of all, we have to know what is distance. What does mean by distance? Anybody can tell, or anybody can chat. What do you mean by distance? Is anything answer? Anybody have answer? Please tell me. Okay, so distance is nothing but total length of the path taken by the object, by an object which that object which travels or covers some distance from one position to another position. Suppose one person at here at A. After some time, that person goes like this and stopped here at B. Okay, so that there is a length between A and B, maybe 20 centimeter or 20 meter, whatever it is. Okay, so now we can take only meter because meter is a SI unit for the length, breadth. Already you know that. Okay, so 20 meter. So that person from A to B, he covers 20 meter length. That length is called as distance covered by that man, covered by the objects, no matter the direction. Okay, so here direction is not used, only total length. Okay, only total length. We have to take only total length of the object, length of the path. So it is a scalar quantity. It is a scalar quantity. Already you know that scalar means it has only value. Okay, meaning it only it has magnitude, not direction. ఉదాహరణకు నీవు స్కూల్ నుంచి వీటికి 3 kilometer முன்னாடி 2 kilometer వెనక్కి நடந்தா distance 5 kilometer. You know that? What does the mean? ನೀವು ಸ್ಕೂಲ್ నుంచి వీటికి 3 కిలోమీటర్ మున్నాయి 2 కిలోమీటర్ వెనక్కి நடந்தா distance 5 kilometers. Yes. So this is the distance. So distance means total path length traveled. Distance means total path. So 3 kilometer forward. So in this example, 3 kilometer forward and 2 kilometer back. So total distance covered by that man, that is 5 kilometer. So it is a scalar quantity. So it has only magnitude only. Okay. Now we can see that one simulation step from FET. You can see here. Yes, you can see here. So here you can see that position, velocity, acceleration. First of all, we are going to discuss about position, that is distance displacement. Okay, that's why this one graph is enough. Now position means that person position 0 meter. Suppose if I enter 2 and click play, so what did you see? The man travels from 0 meter to 2 meter. So that is his position. So that is his distance. Yes, the distance between 0 meter to 2 meter. That is the length. That length is called as distance. Okay. So now, so suppose I put 2 meter per second, right? Then I play. What did you see? Suppose if I put 2 meter per second in velocity tab, the person moves right. So we can set 3 seconds. Okay. So, okay. So, sorry. So take only 3 seconds, which is enough. Okay. 3 seconds. So set velocity 2 meter per second. The man goes height for 3 seconds. Okay. Now I put minus here. So minus 2 meter per second. So now click. You know that again 2 seconds. Okay. So total 5 seconds. Okay. Right. So look, the man, first of all, walks 6 meters right. Then 4 meters left. So total distance. What is the total distance? First of all, the man walked 6 meters. So 6 m. Right. And after that, he turns back and goes 4 meters left. 4 m. So total distance 10 meters. Yeah. 6 meter plus 4 meter. ఆ మనుషులు 6 meters right, 4 meters left ನಡೆದು total distance in the total distance 10 meters. Yeah. So that person 6 meter and then 4 meter. So total distance 10 meter. Is it correct? Okay. Right. And then we will discuss another concept, speed. Okay. Okay. Before that, one question for you. ఎప్పుడు distance 0 అవదు? When is distance 0? So distance 0 in which case or in which state or in which position? ఎప్పుడు distance 0 అవదు? Anybody? When is distance 0? Suppose that this is the object. So suppose if I am saying that distance is 0, what does mean? That means the object does not move at all. Okay. Only if the object does not move at all, that distance is 0. Okay. Okay. Right. So ఇది చూడండి, distance counts every step, no matter the direction. Okay. So now we will go into that next topic, that is displacement. So displacement, which cares about direction, it is the shortest distance between that object starting and ending points. So for example, one person here, he covers this distance, okay, maybe 200 meter, and stopped here. What is that distance and displacement here? Anybody? What is the distance and displacement here? The man starting point here, okay, so maybe A or B, okay, whatever it is. The man starting from this A position and covers 200 meter and stopped here. Okay. So 200 meter means distance. Then what about displacement? Displacement, already I told you, the displacement cares about direction. So in which direction? Already we know that main four direction, north, east, southwest. Okay. So displacement, it is nothing but it is the shortest distance between that initial point and the final point. So this is the initial point and this is the final point. So this is the displacement. This is a displacement. Okay. So it is a shortest distance between the initial point or initial position and final position. Clear? So for example, um, here your school, okay, you at here, you take this path to travel to reach the school. Okay. Someone takes this path. So this is so here length 200 meter. So here length 400 meter. You may think here that is the distance. So first person covers 200 meter distance. Second person covers 400 meter. That is his distance. Yes. Then what about displacement? Displacement is final position and initial position. Yeah, there is a displacement. So this is initial position IP, this is final position FP. So this is a displacement. Maybe 100 meter, 200 meter, 200 meter, nothing, 100 meter, 50 meter, whatever it is. Okay. So shortest distance between an object starting point and ending point, including direction. It is a vector quantity, meaning it has both magnitude and direction. Displacement అంటే ఓకే ఆబ్జెక్ట్ యొక్క ఆరంభ పాయింట్ మరి ముడివు పాయింట్ మధ్యలో ఉన్న షార్టెస్ట్ డిస్టెన్స్. ఇది ఒక వెక్టర్ క్వాంటిటీ, మ్యాగ్నెట్ కూడా ఉండి డైరెక్షన్ కూడా ఉంది. If you walk 5 meters forward and 2 meters backward, your displacement is 3 meters forward. Why? If you walk 5 meters forward and 2 meters backward, your distance also, what is your distance? 5 meter plus 2 meter, already told you, 7 meter. But now the displacement is only 3 meter forward. 3 meter forward. Why? Because it is the net distance from the start position. ಉದಾಹರಣೆಗೂ ನೀವು 5 meters ಮುನ್ನಾಡಿ ನಡೆದು 2 meters వెనక్కి వస్తే నీ డిస్ప్లేస్మెంట్ 3 meters మున్నాడి. ఏంది? ఇది ఆరంభం నుంచి నెట్ డిస్టెన్స్. క్లియర్? సో displacement means final position minus initial position. So it is a vector quantity. So it has both magnitude and direction. For example, 5 meter forward and 2 meter backward means 3 meter forward. This is the displacement. Correct? Okay. Now we can see one case in that simulation. Okay. Now the man at 0 meter. So that his position 0 meter. Suppose I take that man from 0 to 4 meter. Okay. So moving him 4 meters right. Then 2 meters left. Okay. So now his distance 4 meter from 0 meter. So displacement final position minus initial position. So 4 minus 0 meter. So 4 meter. Okay. Now 2 meter left. Okay. Now you can see the position 2 meter. Yeah. So this is a displacement. ఆ మనుషుడు డిస్ప్లేస్మెంట్ ఎంత? ఆ మనుషుడు డిస్ప్లేస్మెంట్ ఎంత? 2 meters to right. Because 0 meter his initial position. After that he moves in the right direction 4 meter right, then 2 meter left. Now initial position and final position, you may know that initial position 4 meter, final position 2 meter. So 4 minus 2, 2 meter. So that is his displacement. So 2 meters right. Okay. So this is a displacement. Okay. So ఇది చూడండి, Displacement is about where he ends up, not how much he walked. Okay, clear? So ఇది చూడండి, displacement is about where he ends up, not how much he walked. Clear? Okay. Let me ask one question to you. Is displacement always equal to distance? Is displacement always equal to distance? డిస్ప్లేస్మెంట్ ఎప్పుడు డిస్టెన్స్ కి సమమా ఉంటుంది? ఎనీబడి హ్యావ్ ఆన్సర్? ప్లీజ్ టెల్ మీ, ఆర్ ఇన్ ద చాట్ బాక్స్ యూ కెన్ టెల్. ఇస్ డిస్ప్లేస్మెంట్ ఆల్వేస్ ఈక్వల్ టు డిస్టెన్స్? డిస్ప్లేస్మెంట్ ఎప్పుడు డిస్టెన్స్ కి సమమా ఉంటుంది? ఇన్ విచ్ కేస్? Distance is path traveled by that man, path traveled by that object. Yeah. Is it clear? Okay. Displacement means, so displacement cares only about that initial point or initial position and final point, final position. Not how much he walked is not considered in the displacement case. Okay. So suppose already I told that one example. Suppose one person walking 5 meter forward and 3 meter or 2 meter backward, then total distance 5 meter plus 2 meter or 5 meter plus 3 meter, 8 meter, 7 meter. Yeah. But in terms of displacement, 5 meter forward, 3 meter backward means 5 meter minus 3 meter. So 2 meter only his displacement. Yeah. Then in which case displacement which is equal to distance? For example, suppose one person moving in a straight line without turning back. Okay. Suppose one person moving in a straight line without turning back. For example, that man here shows 0 meter. After 3 seconds, he stopped here. So this is a distance maybe 25 meter. Okay. After 3 second or 5 second, the man at here. Okay. So what is his distance, or what the like path covered by that man? You can tell, sir, 25 meter. Yes, this is his distance. Yeah, 25. Then what about distance? Sorry, displacement. This is initial position. This is final position. Final minus initial. So 25 minus 0, 25. Then distance equal to displacement. Okay. So only displacement ఎప్పుడు distance కి సమం ఉంటుంది only when moving in a straight line without turning back. That is a case. Is it clear? Okay, right. So now we are going into that another topic, speed. What does mean speed? What do you mean by speed? Already you know that that word, that term, speed. But what is that meaning in terms of physics? You have already studied in a previous class. Yeah. So speed is the rate of change of distance. Rate of Change of distance.
ఆల్రెడీ డ్రాప్ బాక్స్ లో ఉన్నాడు రావట్లేదు అది డ్రాప్ బాక్స్ అట్ స్కూల్ లెవెల్ జెడ్పీహెచ్ఎస్ అలాగే
No, excuse me. Okay. Okay. So speed is the rate of change of distance. So rate of means it depends upon time. So speed is equal to distance per time. Distance per time. Okay. Already you know that distance. So distance per time. So units meter per second. Meter is a unit for distance and SI unit for time is second. Yeah, already you know that. So speed is how fast an object travels measured by the distance divided by time. Okay. So let's talk about speed. Speed is how fast an object travels measured by distance divided by the time. Like distance, it is also scalar quantity. Speed also scalar quantity. No direction, only magnitude. Okay. Speed అంటే ఓకే ఆబ్జెక్ట్ ఎంత ఫాస్ట్ అయ్యి వెళ్దు డిస్టెన్స్ టైంతో షేర్ చేస్తే చూస్తాం ఓకే ఇది స్కేలార్ డైరెక్షన్ లేదు ఓకే సో ఫర్ ఎగ్జాంపుల్ ఒక బైక్ 100 meters in 5 seconds లో వెళ్దే స్పీడ్ what is speed? If a bike travels 100 meters in 5 seconds, then what is his speed? 100 meter in 5 seconds. So distance 100 meters. So 100 time 5 seconds. 100 by 5. 20 meter per second. Okay. So oka bike 100 meters 5 seconds లో వెళ్తే స్పీడ్ 20 meter per second. So speed is distance by time. It is a scalar quantity, that is, it has only magnitude, not a direction. For example, 100 meters distance and 5 seconds. In 5 seconds, then speed will be 100 by 5, 20 meter per second. Okay. It's now we can see that speed in this simulation. Now I can put here 3. So velocity 3 meter per second. So let's play. So that man moves in the right direction. We can take 3 seconds. Okay. Okay, 3 seconds. Here you can see the man at 9 meter. Now, yes, is it clear? So between that 8 and 10, there is a 9. So the man covers 9 meters in that right direction from the 0 meter. Okay. So what is speed? If you have any answer, you can tell me. First of all, the man at 0 meter, I entered 3 meter per second in the velocity tab. The man moving 9 meters in the right direction for the interval of 3 seconds. So time 3 seconds. You know that. Distance 9 meter. Already you can see that. Yeah. Then what is his speed? ఆ మనుషులు 9 meters 3 seconds లో వెళ్ళినాడు. స్పీడ్ ఎంత? Speed and the, I think so. Can I start? సో ఆ మనుషుడు 9 meters 3 seconds లో వెళ్ళినాడు. స్పీడ్ ఎంత? 9 meters is the distance. 3 seconds is the time taken by that object, taken by that person to cover that distance. So 9/3 gives 3. So meter per second. So this is his speed in this case. Okay. Right. Okay. So now we can go into the velocity concept. Velocity concept. Velocity is the rate of change of displacement. That's it. Already I told you rate of change of means it depends upon time. Okay, is divided by time. So velocity is the rate of change of displacement. That is how fast an object moves in a specific direction, because displacement denotes direction. Already you know that. Yes. So how fast object moves in a particular direction, that is called velocity. So it is a vector quantity like displacement. Okay. So velocity and a displacement ఎలా మారుతుంది అనేది టైంతో ఇది కూడా ఒక వెక్టర్ క్వాంటిటీ. క్లియర్? ఫర్ ఎగ్జాంపుల్ for example 20 meters per second means in each direction. We have to add direction here for that velocity. Okay. So if a car moves 100 meters east, okay, we have to add distance or direction. Sorry, direction. So 100 meter east in 5 seconds means 100 divided by 5 gives 20 meter per second east. Yeah. ఒక కారు 5 seconds లో 100 meters ఈస్ట్ వైపుకి వెళ్తే వెలాసిటీ 20 meter per second east. Okay. So this is a velocity. Okay. Now we will share that same simulation. Okay. In the simulation, first of all, sets velocity 2 meter per second. Run for some seconds. Okay. Set velocity to 2 meter per second and run for 5 seconds. Okay, right. You can see that distance 10 meters, right? Yeah. ఆ మనుషుడు ఎంత దూరం వెళ్ళినాడు? 10 meters, right? Now you can see that velocity graph here. You can see that flat line, flat red line. Yeah. So flat line means constant. So in this velocity graph, that flat line denotes a constant velocity. Why? So if I put 2 here, 2 meter per second means for every second that person or that object covers 2 meter only. That is same distance in every second or each second per second. So that is equal distance. Yeah. So in equal interval of time, if the man covers equal amount of distance, then the velocity is called as constant velocity. We can see in that graph by flat line. Flat line means constant velocity. Suppose if I place -2 here, okay? You can see now the man moves backward or left, okay? And also you can see that in the graph below the zero line, yeah? So below the zero means negative. So you can see that negative velocity on the graph because you put that -2 meter per second. Yes. So -2 meter per second means he moves backward. That's why the velocity on the graph denotes that negative. Yes. You can see that below the zero, you can see that flat. There is a flat line because that value is same, -2. Minus means which is denotes a direction. 2 means value, magnitude. So 2 meter per second means in equal amount of time, the man covers equal distance. Okay, right. This is the velocity. This is a velocity. So ఇప్పుడు చూసారు velocity, source, speed and direction. Yeah, velocity, source, speed and direction. So 2 meter per second is nothing but speed. Okay. But what about direction? That minus or plus, that positive graph or negative graph, which shows the direction. So velocity, source, direction also. Okay. Now let me ask one question to you. If the car returns to starting point in 10 seconds. If the car returns to its starting point in 10 seconds, what is that velocity? కారు ఒరిజినల్ పాయింట్ కి 10 సెకండ్ లో తిరిగి వస్తే వెలాసిటీ ఎంత? ప్లీజ్ టెల్ మీ. If the car starting from here, okay, so if the car moving like this in the direction and returns back to same position, that is starting point in 10 seconds, then what is that velocity? Velocity in the here, what is his displacement? So starting point here, the man goes like here, like this, and return back to the same position. So initial position and final position same, sir. So there is no displacement, sir. Yes, correct. There is no displacement. Is it correct? Okay, displacement 0. Then what about the velocity? If there is no displacement, there is no velocity. So velocity also 0. If there is no velocity, sorry, if there is no displacement, there is no velocity. So displacement, if displacement 0, velocity also 0. Is it clear? Okay. Now we can move into that another concept, acceleration. Acceleration. So acceleration, it is how fast velocity changes. How fast velocity changes. Either in speed or direction. Okay. So velocity means it has both magnitude and value. Yeah. magnitude and directions. Okay. So acceleration means how fast velocity changes either in speed or in direction. So positive, there are two types of acceleration. One is positive acceleration. So positive acceleration means velocity increases. Negative acceleration means velocity decreases. Okay. Acceleration and velocity ఎలా మారుతుంది అనేది టైంతో. వెలాసిటీ పెరిగా అయితే పాజిటివ్ యాక్సిలేషన్, తగ్గిందే నెగటివ్ యాక్సిలేషన్, డీసెలరేషన్ అందా కూడా అంటారు. ఓకే, దట్ ఈస్ నెగటివ్ యాక్సిలేషన్ ఆల్సో కాల్డ్ as deceleration. Okay, for example, bike starting from rest. Okay, bike starting from rest and then it's speeding up. So here the bike, this is a rest position, bike starting from rest and speeding up. Then what about acceleration? Here positive acceleration. Yes, because velocity increases. Bike rest లో నుంచి స్పీడ్ అవుదే పాజిటివ్ యాక్సిలేషన్. Suppose brakes applied, the bike will slow down. Yes, this is a negative acceleration. Once we apply brake, the bike covers some distance, but that acceleration is called as negative acceleration. Brake వేసినారు పోட்டு negative acceleration. Okay, so acceleration is nothing but change in velocity by time. Okay, change in velocity by time. Change in velocity means, suppose the man here, his speed maybe that is called as initial speed. Okay, initial speed. This is final speed. Initial speed denoted as u and final speed denoted as v. He has varying speed according to the time and the distance. Okay, so change in velocity means final speed or final velocity minus initial velocity by time, v minus u by t, which is known as acceleration. It is also vector quantity. Okay, for example, now this person that the car has velocity 0 meter per second here, and here 10 meter per second. So this is a velocity here, and that is a velocity here, 10 meter per second. So that car or bike travels from 0 meter per second to 10 meter per second with 5 seconds. Within the 5 seconds, it takes 5 seconds to cover that 0 to attain that 10 meter per second from the 0 meter per second. Then what about velocity? 0 and 10 by taking that 5 seconds only. 1, 2, 3, 4, 5. Okay. So what about velocity? Final velocity 10, initial velocity 0, time taken 5, so 5. So 10 minus 0 by 5, 10 by 5. Yeah, 10 by 5. So 10 by 5, already you know that 2. So 2 meter per second square. So meter per second square is a unit for acceleration. Already you know that you have studied in the previous class. You are well known about that SI units. Yeah, meter per second square. Okay. Now we can go into the same summation for the case of acceleration. Now you can see here acceleration. Now I set acceleration 1 meter per second square. You can see that the man speeding up. Yes, correct. You can see also the velocity in the velocity graph, sloping line. You can see the sloping line. Yeah. So sloping line means changing velocity. Okay. Sloping line means that line going upwards. So that denotes that changing velocity. Suppose if I place -1 here in the acceleration tab, -1 here. Okay. Now you can see that the man moving backward, and in that velocity graph, the graph, that line, okay, going downwards. Yes, below the zero line. So negative value. Velocity graph la mardu acceleration constant అయినప్పుడు. Okay. Velocity graph la mardu acceleration constant అయినప్పుడు. Okay. So in this case, in that moving man case, sorry, one second. First of all, the man at 0 meter. So I put 0 here in the velocity tab and the acceleration 0. Okay. Then play. What do you observe? ఇప్పుడు మీరు ఏమి చూస్తున్నారు? The man stays at the same position, no motion. Yeah, correct. ఆ మనసును ఒకే ప్లేస్ లో ఉండున్నాడు, మోషన్ లేదు. డిస్ప్లేస్మెంట్ అంటే స్థలంలో జరిగే మార్పు. వెలాసిటీ లేకపోతే, యాక్సలేషన్ లేకపోతే మనిషి మూవ్ అవడం జరగదు. కాబట్టి డిస్ప్లేస్మెంట్ 0. ఇన్ పొజిషన్ విత్ టైం గ్రాఫ్ ఒక స్ట్రైట్ లైన్. యూ కెన్ సీ దట్ స్ట్రైట్ లైన్. పొజిషన్ విత్ టైం గ్రాఫ్ ఒక స్ట్రైట్ లైన్ లా ఉంటుంది. ఈ స్టెప్ చూపిస్తుంది డిస్ప్లేస్మెంట్ అంటే మోషన్ లేకుండా మారడం జరగదని. ఓకే. సో దిస్ స్టెప్ షోస్ డిస్ప్లేస్మెంట్ డస్ నాట్ చేంజ్ వితౌట్ మూవ్మెంట్. So displacement is change of position. If there is no change in position, there is no displacement. If there is no displacement, there is no velocity. So velocity is 0, there is no acceleration. Okay, which it shows that the man does not move. So displacement 0. Your position with time graph is a flat line. Clear? Okay. Now we can go into that constant velocity case. Now set 2 meter per second in that velocity tab, acceleration 0. Okay. Now click play. Okay. What happens now to the man and to the graph? ఇప్పుడు ఆ మనుషులు మరి గ్రాఫ్ లో ఎలా మారుదు చూడండి. The man moves steadily in one direction. The position time graph is a straight sloping line. Yes, already I told you that straight sloping line means moving upwards. That's why you can see that that blue line going upwards in that position time graph. ఆ మనుషుడు ఒక డైరెక్షన్ లో ఈక్వల్ స్పీడ్ తో మూవ్ చేస్తాడు. పొజిషన్ టైం గ్రాఫ్ స్ట్రైట్ లైన్ లో మారదు. సో దిస్ మీన్స్ డిస్ప్లేస్మెంట్ ఇంక్రీసెస్ యూనిఫామ్లీ విత్ టైం. ఎస్, ఇది అంటే డిస్ప్లేస్మెంట్ టైం తో యూనిఫామ్ అయ్యి పెరుగుతుంది. వెలాసిటీ అంటే డిస్ప్లేస్మెంట్ ఏంది పాస్ట్ అయ్యి మారుతుంది అనేది. కాన్స్టెంట్ వెలాసిటీ ఉండే మనిషి ఒక డైరెక్షన్ లో ఈక్వల్ స్పీడ్ తో మూవ్ అవుతాడు. పొజిషన్ విత్ టైం గ్రాఫ్ ఒక స్ట్రైట్ లైన్ లా ఉంటుంది. ఎందుకంటే డిస్ప్లేస్మెంట్ ఈక్వల్ అయ్యి పెరుగుతుంది. ఓకే, సో వెలాసిటీ ఈస్ హౌ ఫాస్ట్ displacement is changing. At constant velocity, the man moves in a same direction with the same speed. Yeah. A position time graph is a straight line because displacement increases time steadily. Clear? Now we can move into that positive acceleration case. Now set velocity 0 meter per second, but in that acceleration term we can put 1 because positive acceleration. Now click play. What do you observe in that velocity graph? Velocity graph లో మీరు ఏమి చూస్తున్నారు? Velocity first of all increases with time. The graph is sloping upwards. Yeah, correct. Velocity time తో పెరుగుతుంది, గ్రాఫ్ స్లోప్ ఊపర్స్ పాయింట్ చేస్తుంది. So this shows positive acceleration. That means the man speed up. ఇది పాజిటివ్ యాక్సిలరేషన్ చూపిస్తుంది. ఆ మనుషులు స్పీడ్ పెంచుకుంటున్నారు. ఓకే, నౌ we can go into that negative acceleration, that is deceleration. So we can put velocity here 4 and acceleration here -1. Okay, now click play. Yes, what happens to velocity now? ఇప్పుడు వెలాసిటీ ఎలా మారుతుంది చూడండి. వెలాసిటీ decreases with time. Yeah, you can see that velocity in that velocity time graph. You can see that velocity decreases with time. That means the man slows down. Velocity time తో తగ్గుతుంది, ఆ మనుషులు స్లో అవుతున్నారు. So this is a negative acceleration or deceleration. ఇది నెగటివ్ యాక్సిలరేషన్ లేక డియాక్సిలరేషన్. క్లియర్? సో యాక్సిలరేషన్ అంటే వెలాసిటీ ఎన్ని ఫాస్ట్ అయ్యి మారుతుంది అనేది. కాన్స్టెంట్ యాక్సిలరేషన్ ఉండే వెలాసిటీ ఈక్వల్ అయ్యి పెరుగుతుంది. కాబట్టి వెలాసిటీ విత్ టైం గ్రాఫ్ ఒక స్ట్రైట్ లైన్ లా ఉంటుంది. పొజిషన్ విత్ టైం గ్రాఫ్ ఒక కర్వ్, దట్ ఈస్ పారాబోలా. యూ కెన్ సీ దట్ పారాబోలా కర్వ్ పాత్. ఎస్, ఒక కర్వ్ లా ఉంటుంది, ఎందుకంటే డిస్ప్లేస్మెంట్ ఫాస్ట్ అయ్యి పెరుగుతుంది. క్లియర్? సో ఈ స్టెప్ చూపిస్తుంది యాక్సిలరేషన్ వలన వెలాసిటీ మారుతుంది, మరి డిస్ప్లేస్మెంట్ కూడా కర్వ్ లా మారుతుంది. ఓకే, దీస్ ఆర్ ఆల్ అబౌట్ డిస్టెన్స్, డిస్ప్లేస్మెంట్, స్పీడ్, velocity, acceleration. Is it clear? Okay, displacement. Already you know that. So we can recap all those concepts. So displacement is shortest path with direction. Velocity, it is rate of displacement, that is displacement per time. Acceleration, rate of velocity changes. Yeah, correct. So that FIT simulation showed how they connected displacement, velocity, as well as how they connected. We can see that by using FIT simulation. Yes, displacement, shortest path, direction though. Velocity, displacement, time though. Acceleration, velocity ఇలా మారదు. Simulation ఇది అన్ని చూపించు. Okay. Okay. Now some question. If velocity is constant, if velocity constant, what is the position time graph? Velocity constant అయినప్పుడు position time graph ఎలా ఉండు? This is one question for you for homework or activity. And the second question, this is first question. So the second question, if acceleration is positive, if acceleration is positive, what happens to velocity? Okay. If acceleration is positive, what happens to velocity? Acceleration positive అయినప్పుడు velocity ఏమవుదు? So these are the question to you for homework activity. You can do some other activity like draw a graph for uniform motion, that is constant velocity. Uniform motion ki graph draw చేయండి. Okay. FET simulation మళ్ళీ try చేయండి. Okay. And another one activity maybe పాజిటివ్ మరి నెగటివ్ యాక్సిలేషన్ కి ఒక ఉదాహరణం రాయండి. ఓకే, రైట్ వన్ ఎగ్జాంపుల్ ఈచ్ ఫర్ పాజిటివ్ అండ్ నెగటివ్ యాక్సిలేషన్. క్లియర్? ఏதாவது డౌట్స్ ఉన్నారు? If you have any doubts, you can ask me, or in the chat box you can chat me. So if velocity is constant, what is the position time graph? If acceleration is positive, what happens to velocity? Okay, so see you in the next class. Thank you. வாழ்க பாரதம். ஜெய் ஹிந்த்.